So I'm going to talk to you about simplifying state management with Spring Boot, HATEOAS, and KFSM. So these are a lot of acronyms, and you're going to find out what they mean. A little bit about me. I like to understand the world, and from a small age, I have been applying my mind to the world to try and figure out how it works. These are some of my favorite quotes. A gentleman by the name of Graham Mitchell told me, keep it simple, stupid. Very soon after I started programming, and I think that stuck. It is something to keep in mind. And the elaborate version of that comes from Mr. Einstein, which everything should be as simple as possible, but no simpler. Now, that also means that things can get complicated. And when it comes to developing software, state management is the bane of our existence, especially if you're developing a user interface. So, I'm going to actually first show you the application in action, and then I'm going to show you how the basic design is put together, how we define the state machine, context, how we define a service, and then where HATEOAS comes into play, and how to build a controller that provides that information. And then what does the UI service and components look like? So to start out with a demonstration, I'm going to launch this little application. So this little application launches a turnstile. I'm going to expand this a bit so you can see the turnstile, the first one, which is basically a well-known simple state machine. That means that if I pay with a card, I can unlock the turnstile, and then I can pass through the turnstile and it's locked again. If somebody else pays with a card, it's unlocked, but if you pay with a card again, then it returns it. So there used to be a time, I think in New York City, when the turnstiles was unlocked by a specific coin. I don't know what the value was, whether it was 20 cents or a quarter or 50 cents or whatever, but that's all that you did. You popped in a coin and you could go through the turnstile. And that's what this is modeling. Now, in this app, I can actually create many turnstiles, and I can manage each of their states separately, because in lots of applications, that's the kind of thing that you are doing. And when we have many things, then we can't display them all. We use pages. So I'm just going to go back to 100%, which it was designed for. And you can now see that there are pages, which is another element of the state of the system. So how do we manage all of this? And how do we put it together so that the logic intended is in one place and it's still possible to develop a decent user interface? I'm going back here and I'm going to show you a model which has a finite state machine at the heart, which has two states, locked and unlocked, and two events, coin and pass, or we can call it pay and pass. And the finite state machine model is defined. There is an abstract class that's the finite state machine definition that it will own. And there's an instance which is created for each instance that you want to interact with. And the state machine operates on a context. So the context is the thing that can lock or unlock or return the coin. So the state machine gives the contexts these instructions. And what I had to do is have a separate data class because we want to persist this data and we want to send it to the front end. So the front end gets a data that says it's locked or unlocked, and it gets an ID, and there's a message. You saw the return coin message show up when you press the pay button again. So how do we define the state machine? Well, before we do that, here's a diagram. Some of you may have seen state machine diagrams. So the state machine we want to define has the two states locked and unlocked. The coin event goes to unlocked and the pass event goes to locked. So it performs an action on the context. And if it's in unlocked state and you send it the coin event, it returns the coin. Now that same diagram can be represented in a state chart, which is an unpacking of that information in a way that we can start working with in programming languages and in data models. So we have the same information about the states and the actions. Now, these artifacts are actually generated by KFSM from the definition. And that definition looks like this. So this is Kotlin code. Even though it's iCode Java, we have different tracks. And I did this in Kotlin because Kotlin supports DSLs, which means I can declare the state machine. I say the state machine states are defined by the set because I'm not limiting it to enums by default. The events are defined by that set. The context is defined by that class. I'm not sending it any arguments, but I have a return type from events, which is the turnstile data. So I leave the any class there for just as a placeholder. So the definition says the initial state comes from the current state in the context. The default action is to generate an alarm, which means it will be called when it doesn't match any of the other states. When it's in locked state, it goes to unlock. And when it's in unlocked state, it can either lock it when you pass, or it can return the coin and remain in the same state. So what this means is that the alarm will only trigger when you're in locked state and you get a pass event, which is the equivalent of having a buzzer when you try and push the turnstile. So now we put this together in a set of services. So I have a service that feeds the user interface that you saw. In other words, it can get an individual turnstiles data. It can list the turnstiles. It can send them an event, and it can delete a turnstile. And you can ask it what possible events are available when for this turnstile data given its current state. So that is key in this process. Now I have a persistent context which extends the, which implements the turnstile context from previously. It has an entity which closely matches the turnstile data, and that's going to be saved in a repository because I'm using Spring Boot. What else? And Spring Data. The finite state machine is used by the service to perform the operations when asked to do so, given the context. So the context basically gets created given the data from the entity, from the data, and it loads the entity, and it then creates the Turnstile state machine using the context, and it then sends it the events, or it can ask, answer the questions about which events are allowed. That brings us to HATEOAS. So HATEOAS, that's what I call it. I don't know if there's another way of referring to that acronym, but I'm not going to spell it out. It does mean hypermedia as the engine of application state. And the key terms here are entities, in other words, some kind of data structure. That data structure can also have links. We can have collections of these entities, and we can have pages of these entities. And you saw the pages in action. Now, how do I apply it? Well, I start from the mantra that says, well, I don't want the front-end developer to be building up URLs all day long. Because if I decide to change something, the front-end developer needs to change something. So I have an entry point which gives me the information I need. So if you query my running application by doing a get on the /API, you actually get back this response, which contains a set of links. So underscore links is the convention for presenting the links. And there are 3 links. The first one is self, and then list and create. So self says, well, if you want to find out the links again, you can call self. You see requested version, because what I do is the front end knows that it wants to use version 1. The backend can tell it, no, I don't support version 1, I only support version 2. Then you know they're out of step and you stop it immediately. You don't find out down the line that there's something that goes wrong because the APIs are incompatible. So I change this version the moment there's something in the API that breaks for an older version. Now, create and list can be, the URL is the same. Guess what? List is a get on that URL and create is a post on that URL. So that's something that the developer needs to know. And I also provide them, and if you run this app, you will see there's a Swagger that gets a UI that gets rendered that has all this information. But it is available programmatically. So if we go to the next one, when I invoke create, this is my response. So this is now the response that represents an individual instance of Turnstile data. So the data in the Turnstile data is the current state, the ID, and whether locked is true or untrue, and a message if any. And then links. So there's a link for coin, there's a link for delete, and there's a link for self. I don't know why delete doesn't have an href. That's interesting. We will find out later. So I can send the coin event, but I cannot send the pass event because the state that we're in doesn't allow the pass event. So I have code that checks for the possible events that are available, which ones are allowed, and then those are the only links that I add. So the pass link will not be available, and that is why that pass icon on the front end was disabled. So if I send it a coin event, I get this back. So I get back coin is still possible. Delete seems to have appeared. Pass is now available. And self is always there. So self is always what you used if you want to refresh the data. You can see the state is now unlocked, and the locked flag is false. So the front end can represent this, and because parse is available, it enables the parse option. When I send it another coin event, the state hasn't changed, but you see a message has appeared, return coin. And that is how I'm telling the front end what to show and what to do. If I send it a parse event, then it goes back to locked state, which is what we expected. And now it looks pretty much like when we created it. If I send another parse event, which is not normally available through the front end, but I did this on the command line, you can now see a different response. This was an error response, 409, which means there's a conflict, and the message is alarm, and the path initially was this. So the front end can now represent that, that error if it needs to. So in the case where the front end is misbehaving, you will still get an error. If I ask for a list of turnstiles by doing a get on that API/turnstile, I get back this. So embedded is always the prefix for a collection, and this is a collection of turnstiles. And you can now see I just did a short collection so that it can fit in the page. I asked for a page of size 10, and it comes back and it actually tells me, yes, there is, the page size is 10, but there are, the total elements are 2, there's 1 page, and this is page number 0. So I can represent this. If I have a longer page, at the bottom, you will see I created 15 elements, and then I did this, and then you can see the total of elements is 15, and there are 2 pages, and the page size is still 10. So if you change the page size, then obviously the total pages will change, but the total elements will remain the same. And you can do a query. If you see here, I can say first or next or last, and I have those options on the front end. You saw the arrows for next and previous. The previous arrow was disabled because previous is not in this list because I am on page 0. So I can request a page by number and a page size. So last will actually request page 1. Next will also request page 1. So when there's 3 pages, then last and next will be different. Now, how do I present that to the front end? Well, by building a controller that you accepts a pageable, which means it will basically look for those parameters, page and size, and also sort to create a pageable object that gets sent to the service to request a page of turnstile data. Entity model is the wrapper that provides us with the links. And the representation assembler over here is the one that can create the model, and it can create pages. So it can get the data that comes back from the service. You see the service that I spoke of earlier? This service returns turnstile data and a page of turnstile data. The assembler can translate that into the HATEOAS representation. So that persistent entity, the turnstile entity that you saw, it never leaves the service. It's only relevant to the context, and it's inside of the service. The external data is this turnstile data, and I can ask the service through a static method, what are the possible events given this turnstile data, and it gives me a set of strings with a lowercase representation of that event name, and it's the same event name that's going to come in to the event to trigger the event. Now, our REST controller actually looks like this. It's literally one-liners to invoke the service and then pass the result to the assembler to produce the response. And in the case of list, it accepts pageable. In the case of create, there's no parameters. It's a post, and it calls create on the service and responds with the result. The get takes the ID, and it will send that to the service. In the case of an event, the event is a parameter, and it is sent to the service. And in the case of delete, it's just the ID, and this will throw an exception, and the exceptions will obviously translate into messages like you saw before. The representation model assembler is, there's a class called simple representation model assembler, which I extend, and it basically asks you to provide for adding links to an entity model and adding links to a collection model. So what do? I tell the model to add a list of links given the content. And this class is the one that creates the links. So it uses, there's a bit of magic here. There's link to method on controller class dot get item with self rel, and the rel is that name for the link, the relation. So I create the get and delete by default, and then I ask the Turnstile service for all possible events given this item, and then for each event I add a link to the list of links. And they all call the event method with the ID and the event itself, which is a string that came out of this call. And the name of that link is going to be the event. And I return the list of links. So that is the representation model assembler. And to create a page, there is a separate page resource assembler that will work in conjunction with the representation assembler. As you can see, I actually pass it in here when I tell it to create a model of a page, because it's going to actually call this make links to create the entity model. And this thing actually implements or provides an implementation for ToModel, which creates an entity model from Turnstile data. So that allows the backend to provide everything that you saw. Now, what do we need on the front end? Now, this front end I built in Angular, and I created an API service that can do get operations given an endpoint name. So that is the get that I use for the link, the list of turnstiles, or the post is what I use to invoke on a named endpoint. So where do those names come from? They come from this thing that I call a system info resource. So that very first one I showed you is actually the system info resource. So the API service just needs to know what is the URL to get this system info resource. And it has a set of links because the resource actually extends links. And a link is essentially a map of links. And a link has an href and a boolean that indicates whether it's templated or not. And then the API service uses the Angular HTTP client after it's created a URL and from the link, and it invokes the specific method. And I've added methods that allow you to call self on a paged object and first and last and next and previous, which means that you don't have to write that extra code. Paged is the base class that we will use for anything that is a paged resource, and it contains the metadata for the page. And then page request is the parameter that goes to all these paged requests. And in the case of that first get to get the list, we call get with a page request as the parameter over here. I use RxJS to make this reactive, and but in my front-end code I convert them to promises to make things easier. I just find that the RxJS is it's just a bit easier to manage than the promises, and it's a bit more flexible because you can, if you've got a streaming API, you can send many events and things like that. So the UI classes, what did you see on the UI? You had a list component essentially and a turnstile component, but they need a service, and they don't want to call the API service directly. They want something simpler. So there's a turnstile API service to list, to create, to get a specific turnstile again, given the turnstile resource. So I want to reload that one. Or I want to send an event to a turnstile resource, or I want to delete a turnstile resource. So I'm making it a bit easier to use the API service. The turnstile resource, now you see this is a familiar structure. It extends links because it's going to get links. And the turnstile resource page extends page, and it has many turnstiles. The turnstile has a current state because I want to represent that state on the front end as well, because I want to show you what the state is. And then obviously it uses observable once again. Our page components, so the turnstile list that you saw has a set of methods to list the turnstiles, to create one, to update the turnstile when the turnstile component tells it that it's modified the turnstile, so that it can be updated in the list. And I have a separate pager component that I built to deal with the paging of first, next, and this one can be used on any kind of page of elements. So this component will work with HATEOAS and the Angular Material Pager to provide the paging. I need to add some support for sorting. I didn't have time to complete that. So this component allows me to deal with a list, and the turnstile component allows me to deal with sending the event or deleting it. So those buttons you saw for coin and for pass and for delete are handled by this component. Now, what does that code look like? Listing the turnstiles now looks like this. I've got an error message that I can display. So it's a behavior subject. If you don't know a behavior subject, it's a reactive component that represents a, let's say, single variable and its state, and you can subscribe to changes. So I set it to null. I ask the turnstile service to list. I convert that to a promise. I await the promise and I assign it to a page. This is all an async method. So this is easier to read than .subscribe and this whole nested mess that you end up with. The result I assign to a list of total pages, which is the count of pages. And I take the actual embedded list of turnstiles and assign it to turnstiles, which is also behavior subject of essentially an array of turnstile resources. And that's the list that you see below the page. And then if there's an error, I log it and I send it to this error message, which will actually display if there's a value. When you create a turnstile, it looks like this. We call create, we get the result, and we assign it to created. And oh, there's actually a piece of code missing here because it was supposed to show that create a turnstile. Oh, this one actually just lists the turnstile again. So that's why the list is up to date. And because list you see over here retrieves everything and puts everything in their right place. The code in the component that deals with sending the event will here send the event, await the result. It emits this resource updated that the list is subscribed to. It also checks if there's a message in this data, then it shows the message and it sets a little timeout that turns it off after 2 seconds. And if it's an error message like this, then it turns it off after 5 seconds. And here we have the delete message, the delete method, which will invoke delete, and it emits a null on the resource, which the main component knows, oh, that means something's deleted and we need to just reload the list. The UI code, so I want to just show you this. So here we have the button is disabled if the turnstiles links for coin is not available. And the pass button is disabled if pass is not available. And the same for delete. So this you would do by, for example, let's say there's an operation you only want some people to perform. You can check their permissions on the back end and add the links that they're allowed to use. And that way you can turn stuff on and off. So that is how I control that. So what this means is that the front-end code doesn't have to understand the heart of the state machine to operate with it in a very sensible and friendly way. It can do it without any problems. And it means we don't have to try and duplicate that logic, which is often a big problem. So to summarize, I have a state machine at the heart of it. I encapsulate it as a service. I have a controller that renders the HATEOAS models. My front end can easily consume HATEOAS via named template links. And that allows me to provide a user experience that matches the operation of the state machine without the front end having to deal with all that logic. So if you want to get this, I'm going to make this link available soon after, and I will share it on all the social media platforms. And the source for the code are in these projects. You can hit me up on Twitter if you have any questions or comments, or come and join in on the projects. Use this QR code, please, to complete the feedback form. I'd love to hear some feedback. And thank you for joining us today.